Let's be real for a second. When you think about medical math, specifically nursing dosage calculations, does your heart rate, kind of skip a beat? It is incredibly common to feel that sudden wave of anxiety when you're staring down a complex medication order. And you're probably wondering, how on earth do you calculate flawless dosages without having to memorize like a dozen different confusing formulas? Well, I have some fantastic news for you. There's a highly reliable, foolproof method for this, and it's called dimensional analysis.
Welcome to This Explainer. I am so glad you're here because today we're going to completely demystify nursing dosage calculations, and we're specifically focusing on liquid oral suspensions. I want you to think of our time together as a sort of progressive staircase. We're going to start right at the bottom with the foundational concepts, and then, step by step, we'll build our way up to some surprisingly tricky scenarios. By the time we finish this, you are going to look at these calculations in an entirely new, completely confident way. So, here is our roadmap for today. First, we'll cover the dimensional analysis method. Second, solving for milliliters per dose. Third, converting to teaspoons. And finally, calculating total daily dosage.
Okay, let's dive right into this with Section 1, the dimensional analysis method. Right off the bat, I want you to completely shift your perspective. Please don't think of this as some high-level, complicated algebra. Instead, think of dimensional analysis as, a matching game. We're just lining up puzzle pieces so that the parts we don't need simply disappear, leaving us with exactly the answer we want. So, here are the 4 foolproof steps. Step 1, we always start with the order. What did the healthcare provider actually prescribe? Step 2, we add our conversion factors. Think of these as our stepping stones. Step 3, we cancel out the units. Honestly, this is the fun part. Our main goal here is just crossing out the units we don't need until we hit our target. And step 4, we multiply everything across the top, multiply everything across the bottom, and then just divide. To actually win this matching game, you really need to understand one fundamental relationship, and that is what the provider ordered versus where we want to go. Knowing where we want to go, like what your final target unit is, before you even write down a single number, that is the absolute secret to setting up your problem correctly. It acts as your anchor. If you know you absolutely need to end up at milliliters, well, every move you make is specifically designed to get you exactly there. Which brings us to Section 2, solving for milliliters per dose. Let's actually put this into action. Imagine you're looking at a provider's order for 5,000 micrograms to be taken by mouth twice a day. You head over to the pharmacy and you're supplied with a bottle that reads 3 milligrams per 1 milliliter. Remember our anchor, where we want to go is milliliters per dose. But to get to that anchor, we're going to need a metric conversion table. See, the provider ordered micrograms, but our bottle is in milligrams, so we have to convert. You absolutely must memorize these metric tables so they just instantly come to your brain over time. For this one, 1,000 micrograms is equal to 1 milligram. That's the specific puzzle piece we're going to need. Now just watch how beautifully this all sets up. We start with our order, 5,000 micrograms. Then we multiply by our conversion factor, 1 milligram over 1,000 micrograms. And why do we do it that way? Because micrograms cancel out micrograms. Next, we plug in our pharmacy supply, 1 milliliter over 3 milligrams. And look at that, milligrams cancel out milligrams. So what is literally the only unit left standing? Milliliters. We are successfully anchored right at our desired destination. Okay, now we apply what I like to call the multiplier effect. It's this beautifully simple rhythm. You multiply everything at the top, 5,000 times 1 times 1, which gives us a numerator of 5,000. Then multiply everything at the bottom. 1,000 times 3 gives us a denominator of 3,000. And then we simply divide. 5,000 divided by 3,000 gives us a repeating decimal of 1.666. But of course, you can't exactly measure out 1.666 in a standard syringe, right? We have to round it. Following standard medical rounding rules, we look to the nearest tenth. Because the number in the hundredths place is a 6, which is 5 or more, we round up, making our 1.666 a perfect, safe, and entirely accurate 1.7 milliliters per dose. Look at that. First problem, completely crushed. Let's move along and see how this builds in Section 3, converting to teaspoons. Okay, here's our second scenario. The provider orders 1,000 milligrams by mouth daily. Pharmacy supplies a bottle that reads 2 grams per 10 milliliters. But here's the curveball. The question is asking us to solve for teaspoons per dose. We really have to step up our game here, because now we are crossing over from metric units into household units. First, we need to convert the ordered milligrams into grams just to match our bottle. Then we have to convert the milliliters from that bottle into those household teaspoons. So remember, 1,000 milligrams equals 1 gram, and crucially here, 5 milliliters equals 1 teaspoon.
Let's play the ultimate unit-canceling matching game. Start with the order, 1,000 milligrams. Multiply that by the metric conversion, 1 gram over 1,000 milligrams. Boom, milligrams cancel out. Next, multiply by the supply, 10 milliliters over 2 grams. Grams cancel out. Finally, multiply by the household conversion, 1 teaspoon over 5 milliliters. Milliliters cancel out. See how everything crosses out perfectly to leave us safely anchored at our goal of teaspoons?
So let's use our multiplier effect again. Multiply all the numbers across the top. 1,000 times 1 times 10 times 1 equals 10,000. Now multiply the bottom. 1,000 times 2 times 5 also equals 10,000. And 10,000 divided by 10,000 gives us our highly satisfying ta-da moment. The patient needs precisely 1 teaspoon per dose. Notice how dimensional analysis just kept us perfectly on track, even through 3 separate unit changes. Now, what's really interesting about this next setup is how we handle section 4, calculating total daily dosage.
We're shifting gears to our final boss problem here, and we're actually changing our anchor. We are no longer looking for an answer per dose. We want the total per day. Let's say the provider orders 500 milligrams by mouth every 8 hours, and we are supplied with 150 milligrams per 5 milliliters. Our goal is to find the total milliliters per day. Now, before we even touch the dimensional analysis setup, we have to translate the frequency of that order. The order says every 8 hours. Well, since there are 24 hours in a day, dividing 24 hours by 8 hours means this patient is receiving exactly 3 doses per day. This is a vital puzzle piece we literally have to generate ourselves before we can even start.
Now we set up our continuous equation. Because our anchor is milliliters per day, we're actually going to start with that frequency we just found, 3 doses over 1 day. Multiply that by the order, 500 milligrams over 1 dose. Doses cancel out. We're currently sitting at milligrams per day. Finally, multiply by our supplied bottle, 5 milliliters over 150 milligrams. Milligrams cancel out, and we are perfectly left with our final target, milliliters per day. So the crucial point is to keep that multiplier effect rhythm going right to the very end. Multiply the top. 3 times 500 times 5 gives us 7,500. Multiply the bottom. 1 times 1 times 150 gives us 150. Then we simply take our 7,500 numerator and divide it by our 150 denominator. And there is our triumphant final answer, 50. The patient will receive a total of 50 milliliters per day. By strictly adhering to this dimensional analysis method, we easily sidestepped the common trap of accidentally just calculating a single dose. It really proves that this method can handle absolutely any curveball the pharmacy or your next exam throws your way. And this brilliantly illustrates the 3 core rules we've picked up from our source material today. First, you absolutely must memorize your metric conversion tables. They're the required puzzle pieces for all of this. Second, constantly check your anchor. Always ask yourself, is the goal here per dose or per day? And third, just rely on that multiplier effect rhythm. Always multiply the top, multiply the bottom, and then divide. Honestly, if you follow these steps, you simply can't go wrong. Which leaves us with one final pretty exciting question. Are you ready to use these foolproof steps on your next nursing quiz or your next clinical shift? Seriously, the fear of dosage calculation doesn't have to hold you back anymore. I highly encourage you to grab a practice worksheet, embrace the matching game mindset, and confidently apply your new mastery of dimensional analysis. Thank you so much for joining me for this explainer, and hey, happy calculating.